Yes, student, now I have defined your Fourier series for even and odd functions. Yes, student, Fourier series for even and odd functions. Yes, odd functions. Okay, here. Now, first one we have defined here. Yes, first we have defined the case Fourier series for even functions, and also for the, if we suppose that the f of x is an odd function and f of x is an odd function. Yes, number one, if f of x, yes, if f of x is an even function, yes, in that case, in the interval minus pi to pi, yes, then you get f of minus x is equal to f of x. Yes, clear? Yes, and then from the Fourier series cos nx, yes, you know f of x cos nx, yes, which gives the even, and also f of x sin nx, which gives you the odd value. Yes, therefore the Fourier series become, and the Fourier series, in last video I have defined you the series, this one a series. Yes, f of x is equal to half of a0, this series. In this series, here you see for the even function this term, and this is the an is this one, an is this one, bn is this one, a0 is this one. So from here you get only the term for even functions, only you get an is equal to, yes, to minus pi to pi. You apply the property minus a to a, f of x dx is equal to, for the even function, which become the 2 times. So you can say that 2 by pi, yes, 0 to pi, yes, f of x cos nx dx. Clear? Okay. And similarly, bn, which have the function of sin nx, which is the odd function, so we get bn is 0. Yes, therefore the Fourier series in this interval become f of x is equal to bn is 0. So the series become here from the series. Yes, from here you see that f of x is this. Here this term is 0, bn is 0. So the series, remaining series, which is become half a0 plus sigma n varying from 1 to infinity an cos nx. Yes, you get this one. This series is called where, yes, you see that where an for n is greater than equal to 0, yes, is, you know that here a0 you know that, and an you also know that. Yes, a0 you know that from earlier video I have defined it. A0 is this one, and also an is this one. Okay, here this is the called the for the Fourier series. Yes, Fourier series of the even function. Similarly, I have defined the Fourier series of the odd function. Yes, if so you get here, you get in this form, you get the series is only the, you get the series only the cosine series. Yes, therefore the Fourier series with cosine only. You can say that this is the series with only the cosine series. Yes, the Fourier series, yes, series with cosines only. Yes, yes, here the cosines. So you can also the cosine series. Okay, now next one, yes, next one second one. Yes. If you take, if f of x, yes, if f of x be an odd function, yes, odd function, yes, it in that way then you get f of minus of x, you get, which is equal to minus of f of x, yes, in the interval, yes, in the interval minus pi and pi, yes. Then we say that, yes, then f of x cos nx is odd, yes, and f of x sin nx we get is even, yes, is even in minus pi and pi, yes. Here the function is not changes, yes, so you get that, therefore you get a0, yes, you get this one is 1 by pi minus pi to pi, yes, f of x dx, which is again is equal to 0, and also an, which is equal to 1 by pi minus pi to pi, f of x cos nx dx, which is again you get 0, you get only bn term, okay, as you get only bn, and bn is equal to 1 by pi, you know this term, minus pi to pi, yes, f of x sin nx, yes, dx is again is equal to 2 by pi, yes, 0 to pi, f of x, yes, sin nx dx, that you get only this one. Therefore the Fourier series become this is, the f of x become this is, yes, here a0 is 0, an is 0, so the term become only bn, yes. So you can say the series become only n barabar 1 to infinity bn sin nx, this one, yes. Therefore, and you know the coefficient of bn, you get only this one. Therefore, so it is also called, so this series is also called, here the where you call this is the Fourier series of the cosines only, and this series is all called the Fourier series. The Fourier series, the Fourier series with sines only, okay. Here the term is this one, okay. So these are the cosine and sine series, okay student. I think you know now the sine series and cos series, okay. Now next time I have defined you half range series, okay students. Thank you.